You feel relaxed?
Yeah.
Okay. So it is Tuesday today, and the date is 6th October. Please turn to page number
657.
It's 657. No, it's only 57. Okay. So yesterday I taught you about diffusion and osmosis, right?
Yeah.
Briefly, Wateen,
Yeah.
can you go and get something to show me diffusion today? And Malak,
Like what, miss? Okay. Like what?
You have, yes?
Like water bottle.
I just need a glass of water with some color.
I'm going to bring a glass of water.
Okay.
So I take some water and color it?
No, you can bring a glass of water and put some drop into that changes the color. Any drop.
Miss, I dropped what? 1 minute. 1 minute, miss.
Think of it, yeah.
Fill a glass of water.
Okay, don't fill it up full. Make
I put this much.
yeah, okay. Do you have any color to put it inside?
Yeah, I have paint left here. Which color, miss?
Anything what you like here. Anything what you like.
I'll choose this color. Do I use white colors or?
Okay, just show me the color first. Yeah.
I use
this is something, wait a minute. This is something high concentration. What is it called?
High concentration.
Show me the paint. Show me the paint.
I have
this is high concentration. Yeah, use the left one, not the tube. That one is liquid, right?
This one, no. This one's like glue, glitter glue.
Okay, no. Use the other one, the paint. So this is high concentration. When you put a drop into water, it goes. You know the particles. The particles they try to spread over. They try to spread over into low concentration.
Yes, I have also.
Okay, wait a second. Okay. Wait a second. You tell me when you see the liquid, yes. But you need to show. Put your hand up. The glass of water, yes. Little more up. Little more, yes. Now we can see. What happened? Yeah, no, show, yeah. Wait a minute.
I put more?
Wait a minute. I think this is oil paint. Not
no,
mixed?
this is a clear click.
Okay, you don't have a watercolor? Show me. Let me see.
Yes, I have watercolors, miss. I have fabric and water and this one. Here it is.
Because I need to explain you diffusion and you need to do a small activity to show how the particles move from higher concentration to lower concentration.
I'm gonna use the same color, miss.
Okay. Come on. You need to say me that this I am doing as diffusion. This is called as, what is this called, Malak? This is called?
Diffusion.
Yes. All right. What are you doing? You're putting?
Blue paint in water. Yes. But some of it is floating, some of it is sinking, and some of it is making the water blue.
Yes, the one which is making the water blue, the particles are diffusing inside. What will you say? Tell me, Malak. Yes, this is called as diffusion. The particle diffuses from what? From what concentration to what concentration?
Miss, if we mix it, what will happen?
That's what I'm saying. The particles from higher concentration to lower concentration.
Miss, what will happen if we mix the blue
The
color?
particles from the paint. Okay? The particle from the paint will go, that is high concentration. You will say it's high concentrated. It will go to the water where it is low concentration. Don't do that, Valak. Vateen, can you show me some activity?
Blueberry juice.
Miss, I don't have a paint.
Okay, go and get a tea bag. You can show with the tea bag. You know, because tea,
Oh, I have, Miss. There was tea in this before.
you have tea
I
bag.
want a tea
Vateen?
bag.
Yes, you
Yeah,
can
I
show me
have.
with the tea bag.
I have a tea bag right here, Miss. I guess.
No need, no need, enough. Keep it side. Just
But
tell me, what is this called? This is called diffusion. What is this?
Diffusion.
What happens in diffusion? The particles move from
Particles will diffuse the water. Infuse it.
from higher concentration to lower concentration.
Lower
Particles.
Miss, I get a tea bag with water.
Show me. Turn on your camera, my sweetie. Yes.
It's getting more blue.
And explain me diffusion. Yes. Okay. The particles are spreading more.
Miss, do you want me to open and get this black
Yes.
inside?
First tell me which one is highly concentrated. Vateen, you need to explain me. I think you can do it. Come on, Vateen.
Okay, so the diffusion is like a movement,
Hmm.
is a molecule that it's from high concentration to low concentration.
Okay.
Yeah, and
What
the
are
tea
you
bag is
using?
high, right?
What?
What are you using? You are using a tea bag and water.
Yeah, tea
Now
bag.
tell me which one
The
is
tea
highly
bag is
concentrated? Which
What?
is highly concentrated? Water or tea bag? Which one has high concentration?
The tea bag.
Very good. Now what you do? Explain. Explain and do.
Okay. Miss, do you want me to
glass.
open it and get it
Put the
inside?
glass up. Put the glass up, my dear. Yeah, now show me.
Do you want me to open it and get it inside?
No. Don't open it. Just dip it inside it. The particles will spread. You will see the color change. Yes. I know the water is maybe cold. It will take.
No, it's hot.
It's hot. Okay, come on, show me now. Is
You're
the
gonna drink tea today, tea.
is the particles? Is the color changing of the water?
No.
Not much. That means the particles, because it's not warm water, the particle is not diffusing.
Miss, I got cold water. Diffused.
Okay, you can try to tear the what do you call as the paper of the tea bag.
Yeah, you cut the tea bag.
Yes.
Just to the scissors.
Little bit, yeah, little bit, yeah. Be
Miss,
careful,
imagine
Bala.
if you think this is blueberry
Okay.
juice and it's
Good.
let's drop it in the water. Now it changed color, right?
Now do you see
Yeah.
it? Now show me the diffusion.
Yeah, it's yellow now.
Yeah, now show me the diffusion. Yes. See, the particles will diffuse inside the water. This is from higher concentration to lower concentration.
Lower concentration.
Team, do you understand now?
Yeah.
Do you like to show me something, Yali?
Miss, I want to mix the water.
Wash your hand and come back. Mateen, put it in.
What?
You can put it
Miss,
aside. wash
I'm
your
gonna
hand.
mix the water and the paint, okay?
Okay. because Malak, that's oil paint. That's the reason it is taking time.
No,
You know, when oil is there,
it's not the oil paint. The first one is acrylic. The second one is fabric. The fabric is so like water.
yes.
It's become
There's
like
a
a
little
tea.
bit down.
Yes, it is
I
getting
have
more
to
diffused. The
Yeah.
particles are getting more diffused inside. Okay?
Diffused.
I think it was a
Yeah.
small activity. Did you enjoy something?
Yeah.
Yeah, Miss.
Let us continue.
Now we have blueberry juice and that.
Please keep it aside so that you don't spoil your book or don't spoil your, okay? Keep it aside or keep it back in the kitchen and come back quickly.
Okay.
Okay. Cells often need to move material across the membrane from areas of low concentration to area of high concentrations. See, sometimes opposite to passive transport, they also need to move from low to high concentration, right? Sometimes they need to move from low to high. Instead of high to low, sometimes these cells, they often need to move the material from lower concentration into areas of higher concentration. So this is the opposite direction of passive transport. Active transport is the movement of particles against a concentration and requires the cell to use energy. Some large particles that do not fit, you know, girls, when it goes from lower to higher, some, you know, higher to lower, sometimes the big particles, they cannot fit in the protein channels. So they require active transport. Sometimes the large particles, they cannot fit inside the smaller particles. So what happens? See, imagine you have a box and you want to put things inside which is bigger than the box. Is it possible?
No.
No. So
No,
that
that's
time, similarly, some
sensible.
things happen like that in our body, in the cells. So that time we use something called as active transport. Okay, imagine.
Like if you want to eat a burger and your mouth is so small.
Yes, so you need to have some other way out. You need to cut it into small pieces.
It's a piece, yeah.
Active transport, and this active transport have two processes. One is called as endocytosis and the other is called as exocytosis. Again, one is the endocytosis and the other is called as exocytosis.
Miss, the diffusion is from high concentration to low.
To low, yes.
And the osmosis is from
low to high, yes. But for grade 6, you just study that it is in water what they have written a line. That's it. Now here girls, active transport is carried out by two processes, endocytosis and exocytosis. Girls, when I say endo, en, like something coming inside. When I say exo, like exit, something going outside. Will you remember this? Endocytosis, something coming in.
Inside.
Exo is like exit.
Exit is exocyte is something outside.
If you want to put like a big roller in you can't miss, except it. But if it can miss.
Like that, similar.
If it can bend.
Inside our cell, some processes cannot happen because these higher molecules, they don't have space inside to diffuse.
Yeah, like when you're going to kids' clothes and you want to wear it, you can't.
Yes. Yeah. So like that, active transport is carried out by two processes. One is called endocytosis and the other is called exocytosis. Okay. The process by which a cell uses energy to surround the particle and enclose the particle in a vesicle. Girls, imagine there is a particle which wants to go and enclose inside some vesicle. What is a vesicle here? Vesicle means they want to come inside the cell. Some particle want to enclose itself. The cell comes into contact with the particle. And then this cell wants to take the particle inside and cover it. So when this particle goes inside, vesicles or sacs form pieces of cell membrane. Girls, this form like a sac. You know, like what is a sac? Sac means it is a bag, small bag. Now imagine.
Miss, I didn't understand.
Wait here. Latin, I will repeat. The process by which a cell uses energy. Definitely, cell, if it's working or if you want to work, you need some energy, correct?
Yeah.
Cell is using energy to surround this particle. What the cell wants to do? It wants to take this particle and it wants to surround.
Cover.
It wants to surround it. Okay. So that time the cell needs some energy. The process by which a cell uses energy to surround a particle and enclose a particle. It just does not want to surround. It also wants to enclose it. It wants to, see, enclose inside. Enclose means, like example, you keep something in the box. You don't want to keep it open. You want to enclose it. You want to close it. Enclose it. The particle is inside and enclosed by the box. Because you have closed the box, you say that the particle, it's like a English sentence. The particle is enclosed by the box. Okay, like that. This particle wanted to enter, surround, and then finally get close inside that. Okay, so this process, during this, hello? Hello? Hello, can you hear me?
Yeah.
I don't know what happened. Okay, so now this is called vesicles are sac. You know, this is sac formed from pieces of cell membrane. Anyways, it becomes like a small bag here. Okay, it becomes like a small bag here.
Small bag.
Cellular organism such as amoeba use endocytosis to capture
smaller
or
organism.
food. You know, amoeba is one cell.
No.
So amoeba, I have shown you last year in the lab, the black color, one cell. You also have drawn it, maybe you forgot. Anyways, single cell like amoeba want to trap the particle and enclose inside like that. It's food. Amoeba wants to trap the food inside it, okay? Because amoeba itself is one cell. Do you understand endocytosis?
Yeah.
Endocytosis means?
Like, Miss, how can it go around it? Like, close around?
My dear, it want to go and feed it. You know the particles are moving. The cell is moving. Yeah. It goes in and try to trap that particle and enclose it and close it inside. Okay?
So it want to get inside.
Yes, the process by which a cell uses energy. The process by which a cell uses energy to surround a particle and enclose the particle in a vesicle to bring the particle into the...
Yes, we highlight it.
Endocyted. Of course,
you will.
Yes, you will highlight it. Okay, now. Did you highlight it?
Yeah.
Okay. Coming to exocytosis. When particles are enclosed in a vesicle, you know, after endo, where is the particle? It is inside. You know, after endo, it's inside, right? Now see what happened after endo. When the particles are enclosed in a vesicle and released from the cell, now it wants to go out. Now this particle wants to go out. When it is released, you know the meaning of released, Malak?
Yeah.
It comes out.
Get out.
So this is called as exocytosis. Exocytosis is the reverse process of endocytosis. Because in endocytosis, the particle wanted to get in. But now here in exocytosis, it wants to release. It wants to go out. Exocytosis begins when a vesicle forms around the particle within the cell. The vesicle fuses to the cell membrane. It goes and sticks to the cell membrane, and then it releases outside of the cell. Do you see in the picture how it goes outside?
Yeah.
So it is also very important.
It looks like little fishes. You know, the frog missed the small things. Yeah,
yes, exactly the particles, see, particles when they were close, you couldn't see like this. They were highly concentrated, but now it is going into the air. So the particles have too much space. They have too much space and it will go around in all directions. The cell releases the particle to the outside. I'm sure you understood endo and exocytosis. And
Yeah.
Yeah.
particle wants to go inside the cell and get enclosed, surrounded and enclosed. And here in exocytosis, it wants to release outside. Now, finally, the last page. How do organisms maintain homeostasis? As we
Yeah, Miss,
said,
did the things get you in the website?
what?
Did you find the stuff in the website?
1 minute, my dear. 1 minute. Just give me a second. I've read cells can obtain energy, divide and transport material to maintain stable conditions. You know that, right? First of all,
Yeah.
what is homeostasis? Homeostasis is maintaining internal condition, your internal state with the temperature. I
Miss,
think
I made the flashcards of this lesson.
very good, very good. I saw your email also. Excellent, dear.
You find it?
Yes, I find it. Now, what is in homeostasis? Our body is maintaining the internal condition with the temperature. In multicellular organism, the cells must work together to maintain homeostasis for entire organism. You know that, girls, if my body doesn't maintain my internal condition, how I am going to go to the North Pole? If I want to go to Switzerland, my body must Switzerland, yes. My body must maintain the internal temperature, right?
Yeah.
If
So you have to wear jackets over
jacket, and your body must also adjust so much of cold even after waking. Yes, look at her. From now she's in Switzerland. And okay. So, Mateen, can you read this? For example, some organisms. Mateen?
Okay.
Yes, when some organisms become cold.
Miss me or Wateen?
Okay, Leen, you continue, and then Wateen will read.
When some organisms become cold, the cell respond in order to maintain a normal internal temperature. Muscle
Cell
cells will contact
to
to
generate heat. Girl,
generate heat.
this point is very important. You know that when I work out, my muscles, they contract, right? They contract.
Yeah.
When my muscles are working, I feel hot. The temperature of my body increase. It's a cold weather outside. But if you are running, cold? If you're running, will you feel cold? Or if you're sitting at one place, you will feel cold? When will you feel cold?
Yeah, if you're
When I'm going
sitting in one
outside.
place, you'll be. If you run
Even outside, you go to a beach. There, if you're playing around, will you feel cold? Or if you're sitting at one place, when will you feel cold?
If you're sitting in one place, you'll feel cold, Miss.
Yes, because when you work, your muscles contract to generate heat.
Even when
Muscles, they produce heat.
Cold air will
And
come to
girls,
you.
you know, I don't think so you know this. You know why do you shiver when you feel cold? Why do you shiver? What happens sometime now in Jeddah in December when it's cold, you wake up early in the morning to come to school. What happened after washing your face?
Yeah, even after
You shiver.
when you're swimming in the winter.
Yes,
after
your body.
coming from
Why?
school.
Subhanallah, your body automatically starts moving so that you feel less cold. When your body starts shaking, that will release heat from my body.
Yeah.
Malak started to dance now. She's showing you the experiment of how we shake. Yes, Malak? Okay, so what happened, Malak, when you shake like this? When you shake like this, okay, your temperature,
Goes away.
yeah, you know, your body releases energy, okay?
Miss, what we highlight?
Do you see what
Do you
is
highlight
underlined there?
muscle?
Please highlight those.
Okay.
Okay, some example, some animal adapt their behavior to control body temperature. Many reptiles bask in the sun or seek shade to regulate their internal temperature. When temperatures become extremely cold, some animal hibernate. Girls, do you know the meaning of hibernate?
Yeah. When the animals store food.
No. They sleep. We say the word they sleep. Actually, they're not sleeping. They are maintaining their temperature. They sleep 6 months. They
Yeah, in the winter
the
because
winter.
they don't get cold.
They sleep all the summer. Or they sleep. Actually, their
Miss,
body.
they sleep 6 months. Why they store their food in their home and 6 months they sleep?
Look what
Then they
that's
eat
what.
and go back.
When they stay in such conditions, very, very cold temperature, there they try their body hibernate. I will show you the video, inshallah, tomorrow because today I don't have time. You will understand more better about the word hibernate. Because usually kids think hibernate means sleeping. It's not sleeping. Your body is actually taking rest to hibernate, to maintain this homeostasis.
No, Miss, I remember that we learned in grade 3 that hibernating is like when you, because when you stay awake in the cold, you will have to eat food. But when you're sleeping, you don't have to eat food.
Yes, you see
So
that.
that's why you're saving.
You are somewhere near to the answer. I will explain you tomorrow, inshallah. Some trees lose all their leaves around the same time each year. Tomorrow is our science revision. I will revise and I will explain you this. Some
Our quiz
all their leaves around the same time each year. This is seasonal response. See, even plants, they're responding to maintain the homeostasis.
Miss, we will tomorrow revise for the science.
Yes, I will revise with you science.
Tomorrow we have an exam for religion.
Really? Good luck, girls.
What do we have exam tomorrow?
Having bare, what is the meaning of having bare branches?
Like they don't have leaves.
Without leaves.
Bare.
Without bare branches means branches without leaves. It's like you can say they're naked. They don't have leaves on that. During the winter, reduces the amount of water loss. Leaves may also change color before they fall. You know, they become yellow and then they fall, right?
Yeah.
Because that time they don't want to make food. Chlorophyll, you know, the chlorophyll is must. So now the
chlorophyll
is absent. Will it be green in color? Because chlorophyll is green. So when chlorophyll is absent, it becomes yellow in color. And then they fall.
In the autumn they fall, right?
Yes,
the chlorophyll.
Yeah, but Miss, in the winter, why do they fall in the winter?
The leaves gone in the winter.
They want to maintain the internal body temperature.
Miss, actually, when I go to Turkey in the winter, we go to a borsa. Okay. When we go to the streets, the tree, there's no leaves.
Okay, yes.
There's only the trunk.
That's why, because it's trying to...
No, Miss, I want to Kuala Lumpur. I think it's
trying to maintain the tree. Thank you. Then I have to continue my class for the next, inshallah, tomorrow with grade 6, okay?